So hi everyone, my name is Mark Chen with Skanska here in Seattle with our sustainability team. So today I will be talking obviously about structural steel, specifically our A1 through A5 embodied carbon calculations and how we've been approaching that as a general contractor. I'm fairly confident that all the folks on this call here are very familiar with the life cycle stages and what I'm talking about with A1 through A3 and A4 through A5. But just as this graphical depiction shows, we're talking about A1 through A3. So a lot of what Nucor just displayed of our manufacturing emissions associated with our steel, and then A4 through A5, what it means for us to then get that steel to fabrication shops, and from fabrication shops to our job sites, and then installing the steel and erecting steel on our job sites. So obviously, like we've talked about before, EC3 is all about A1 through A3. That's where the system boundary is cut off. At least for now, EC3 is working on A4 and A5 plugins, but it's not currently available. And then so A4 and A5 is then kind of a Skanska methodology on how we track that. So before we get started, I want to take a moment. So this is something that Skanska and a lot of our general contractor friends also do, but we take safety moments or value moments during our meetings to highlight just really bring safety and the culture of safety to the forefront. So I just want to acknowledge that when we're talking about steel, there are many hardworking iron workers that are currently erecting and installing steel on our job sites who literally risk life and limb. They're at the job site like 5:30 in the morning at the crack of dawn, and they work really, really hard in a very dangerous profession. So I think it's important to acknowledge that when we talk about steel, because it's something that, hits home for us as a general contractor. And a lot of these people are folks that I've gotten to know in the past. And yeah, like I said, I just want to highlight them because I don't think they get their due all the time. So when we're thinking about the project timeline, from design through procurement and construction, obviously the GC has tons of influence when it comes to project procurement and construction. And so we talked about specs earlier. A lot of the times, structural engineers and designers will not specify, what mill we source our steel from or which fabricator we choose to work with. That is very much a general contractor discretion. And so it's really important to acknowledge that, because I'm going to quote Dave Walsh here, but the climate and the atmosphere doesn't actually care what our tally or EC3 models say and what the numbers are. The atmosphere cares about what we actually purchase. And so that's why it's super, super important that the GC is heavily, heavily involved in this whole process. And I will get into that here. So during our steel procurement, when we bid out either rebar or structural steel bid packages, Skanska has made a commitment on all of our ground up projects that we are going to evaluate our concrete, rebar, structural steel, and asphalt subcontractors and suppliers for embodied carbon during the bid award process. So again, that goes for all of our projects. And so we have the standard RFP language that we will put into all of our bid packages for those scopes of work. And what we're trying to do here is mainly just send the signal to the market that we care about embodied carbon, and we are going to include it as an award criteria alongside cost, schedule, backlog, everything else that we consider when we award like a fabricator for steel. And so we want to do that again to move the market, send the message that this matters to us. And then also we want to be able to reward good work like Nucor. Come 2022, I plan to write into this template language something about asking for alternate pricing for the iconic product offering. So we want to incentivize, suppliers and manufacturers to do that good work. And at the same time, we want to communicate feedback, and we'll get to this in the next slide, of, maybe companies that aren't doing as much. So this is what it kind of comes down to when we get to procurement. We've received all of our bids back. We've received the information that we asked for at time of bid. So kind of, I know there's a lot on the screen right now, but going kind of counterclockwise, the top snapshot is just our standard rebar embodied carbon reporting form. And it's the exact same concept. And sorry, give me 1 second. My dog is not cooperating right now.
I was wondering if that was a dog.
Shana, this is when you need your Spotify playlist.
Oh yeah, I need some embodied carbon music to fill in.
Sorry, I know, very unprofessional, but we got that taken care of. So anyways, like I was saying, top left is our standard embodied carbon reporting form for rebar, but same exact concept for structural steel. So we'll ask our fabricator to tell us where they're sourcing all of their steel from on a mill basis. So that is one of the biggest, we just talked about it, fabricated versus unfabricated. We, at least at Skanska, we're asking for the unfabricated GWPs and EPDs because just like how, the Nucor team explained, there's the steel that comes out of the mill, just the raw steel. It gets sent to a fabrication shop, and then based on the project specific requirements, a number of things can happen to that steel. Typically, fabricators will cut pieces to length specific to the project needs. There might be, like for wide flange, there might be pre-drilled connections that are incorporated into the steel. Fabrication shops might pre-weld stiffener plates onto the wide flange. There's all kinds of things that can happen between when the steel leaves the mill to when it gets to the fabrication shop. So for that reason, to make sure things are apples to apples as best as we can make it, we ask for the mill specific EPDs and sourcing. So that's a really important thing that we look for. And so once that's happened, we can compile all that information. And for those who might have been on the concrete CLF meeting from before, we'll present in the bottom left the data from EC3 for A1 through A3, similar to how we would present costs. So in this specific project example, we had two fabricators that were sourcing 100% of their rebar from Nucor Seattle. Meanwhile, we had two other fabricators sourcing from Oregon, Arizona, even Oklahoma. So with all that information in EC3, we were able to determine at time of bid that this is what our spread looks like. And we were able to communicate this to our client and say, in this case, one of the fabricators sourcing from Nucor was also the low bid. So it was a no-brainer. We should award them. It's good for the project budget. It's good for our embodied carbon. It's good because Nucor Seattle is the most local mill that we have. It's just a win across the board. So that's just an example of how we've communicated this and incorporated it into our award decisions. And then of course, on the A4 and A5 side, when it comes to transporting that steel from the fabrication shop or from the mill to the fabrication shop to the job site, this is not attached to rebar, but more for structural steel. And I'll get into this in my next example. But one of the biggest opportunities at time of bid is to address the potential for just 100% domestic source steel instead of going overseas. And then if I actually go back for A5, there's a lot of fine print in this little snapshot, but we do ask at the very bottom for our fabricators now to provide us their, our erectors to provide us their electrical needs for like their welding and air compressors, because we've learned the hard way that if we don't get that coordinated with our electricians early, it will result in diesel powered equipment on site when it comes to install the steel. So again, throughout this whole process, we want to communicate like these bid results in the bottom left. So of course, we want to say Nucor, hey, you're doing great. Keep up the good work. On the flip side, for like CMC, we want to show them this information and say, your embodied carbon emissions are really high. What are you doing to lower them? Because right now it's making you look really bad when it comes down for us to make award decisions. So essentially you're going to lose work if you don't, figure this out, which obviously is a very powerful way to, again, move the market for those who maybe don't pay too much attention to sustainability, but obviously care about selling their product. And I'm really happy to report too that we've seen examples of that kind of communication actually creating action within the industry, not specifically with steel as of yet, but like with carpet. We did this exact same thing for carpet and showed one of the manufacturers that they did not get the job because their embodied carbon emissions were high, and now they're working on a net zero carbon product. I still don't really know what that means yet, but it's a step in the right direction. They're paying attention. So specifically going to A4, so our transportation emissions. So for like wide flange steel, where is most of our domestic steel coming from? This is just a general graphic depiction. I did not make this super precise, but just to give you an idea of where most of our wide flange steel is coming from, it's not coming from the West Coast. Most of it is in the Midwest or the Southeast. So you can imagine that your A4 emissions, there's going to be a lot of energy and emissions expenditure to transport our steel from those mills to our job sites here in the great state of Washington. And so that being said, I did also want to touch on the domestic versus international or overseas sourcing example. So this was an actual project where we looked at this for about 230 tons of wide flange. And so Shayna talked about the AISC database for steel and where different shapes are sourced or where they can be rolled at different mills. And so this is a shining example of that because, you know, like Shayna pulled up, if you have a W44 by 335 section, a real beefy wide flange, it's going to limit our ability to source domestically and potentially source from EAF sources. And so on top of that, there's obviously a lot of emissions associated with shipping steel across the world, potentially through the Panama Canal to our job sites. So this is just the rough numbers that we calculated. So let's say we have 230 tons of wide flange that we could either get from overseas or here domestically. So the baseline is this route. This is getting steel from Luxembourg. So you can see just graphically how long that steel has to travel just to even get to our fabricator up in Canada and then down to our job site in Washington. Conversely, if we are able to address this at time of bid and throughout the procurement process, we can get ahead of this and evaluate what it would mean to source domestically. So on this project, there was a cost premium, but we also saw a benefit on our lead times because obviously, you know, there's less travel involved. So this is another good example of with sustainability, if we can find a way to communicate improvements outside of just carbon, it helps our case. If we can frame it as risk management, that will get a lot more decision makers' attention than just saying, oh, we're going to reduce 110 metric tons of carbon pollution, which obviously is important, but you know, not everyone speaks that language. So when we're able to introduce risk and risk mitigation into the picture, that hopefully helps us get the decision we want, because, you know, obviously this is not applicable to this area geographically in the world, but as we saw in the Suez Canal, however long ago that was, shipping things across the world can have risk and things can happen where, you know, we might not be able to get our material in time. So A5, this has been really, really fascinating for us on the construction side because all of it obviously includes things that happen on our sites. So A5, some of the things that contribute to that A5 bucket of emissions: tower crane, diesel mobile crane, welding rigs, air compressors, gas-powered chop saws. Those are just some big, like when you actually walk on a job site, some examples of things you'll probably see. So it's been really interesting to track this because Skanska has been tracking it on our job sites for a few different projects. So we've been able to collect some interesting data, normalize it against, you know, like how many kilograms of CO2 are we emitting per ton of steel erected. So 10 to 15 kilograms is about what we've seen on a handful of projects. Obviously, we just started this process. We're trying to grow that data set. And then just some simple reduction best practices. If we can't, you know, I talked about electrification of our equipment on site and coordinating that with our electricians. If for whatever reason that's not possible, then we want to use renewable diesel in our equipment, which is, we could do a whole nother presentation on renewable diesel, but different from biodiesel. I won't get into the details, but low carbon, low emissions fuel. Obviously, the better option is to electrify everything. So that's where we need to, you know, at time of procurement, get things figured out early on. So logistically, we can work with our electricians to provide our steel erectors the power they need. Because otherwise, so that middle photo is an actual picture from a job site recently where our erector had to roll out this giant diesel rig to power their welding operation. And so it's things like that where we walk on site and see that, that's where we go, okay, we need to get this into our RFPs and bid packages so that we address this, because what happened here was, you know, like a lot of things, no one thinks about it until, you know, our steel erector is about to show up on site in a week. And by that time, it's too late to do anything about it. And of course, we've also, as far as electrifying everything, if we can, at least for the time being, if we can purchase renewable energy certificates for our temp power on site, which is something we're looking into. That's obviously kind of going above and beyond, and then also looking into on-site renewables. So as far as things coming down the pipeline that, you know, give us hope of how can we, you know, there's the SC 2050 commitment, how can we even think about getting there? You know, obviously we talked about Nucor's Econic product offering and certification. So that's a great step in the right direction. There's also some stuff going on overseas in Sweden. There's this company called Hybrid that's manufacturing steel from fossil-free electricity and hydrogen. I've seen this MOE, molten oxide electrolysis process, where you can manufacture steel basically with just iron ore and electricity, like no combustion involved at all. And then on the right-hand side, we've looked at, we saw, if you go back, that picture up top with the giant mobile crane, that thing is definitely running off of diesel. So I know manufacturers like Liebherr are starting to manufacture all-electric mobile cranes. And so the battery technology is still kind of fringe of what we can actually make work on our job sites, but it does, again, give us some hope for the future. So if you're wondering like what we've seen as far as the spread between A1 through A3 versus A4 and A5, this is generally what it's come down to. This is for one actual Skanska project that's nearing construction completion. So obviously A4 and A5 are all predicated on all of our construction being done, which, we just started tracking this a couple of years ago, so we don't have a ton of data, but it's about 88% A1 through A3, 10% A4, 2% A5. So that gives you, again, kind of the scope and overall big picture of what we've seen. But one thing to note is when we track our A4, there are certain accounting gaps that might exist, because like for certain projects, we've just cut off like whatever mileage we're tracking for transport is cut off at the fabrication shop to the job site. Because for certain materials, that supply chain after the fabrication shop can get so complicated. So this number is probably missing some emissions from mill to fabrication. So I would expect that number to be a little bit bigger, not by a ton, but just a caveat there. And then just checking myself on time, I know we're over, but it's really easy to get stuck in the bubble of only looking at carbon dioxide numbers. But for us, like we looked at that pie graph and it's easy to say like, oh, A5 is only 2%, like we don't even need to pay attention to it. But for us as a general contractor, A5 is what affects the air quality on our job sites. It's what our workers are breathing on a day-to-day basis. Same thing with A4 when it comes to trucking huge pieces of steel on freeways and city streets, creating air pollution in our communities. Same thing for just having to refine oil into diesel fuel. And, just like Nucor showed earlier, there are very tangible and visceral impacts of like BOF powered steel and what that can do to a local community and air quality and overall public health. So I just want to bring that to the table too, because again, it's easy to look at the numbers and say we shouldn't pay attention to one of these things, but there are real impacts that we might not feel, but that others will feel because of the work we're doing. And so with that, I just threw in this goofy photo because I sent Shayna this a few weeks ago. I was like, what if we put solar panels on tower cranes? Because that's like a perfect place for solar panels, but probably not a good example for Seattle because most of the electricity is already very clean. But I don't know, just threw that in there for fun.